recording this meeting, so I'm going to switch on the recording. Oh, okay, Emily started it. Okay. Thanks, Emily. Welcome. My name is Phoebe. I'm the product manager for NaPTAN. And if we could have next slide, please. We are going to be focusing on 910 railway station data for this meeting. The agenda will cover meeting the team, an audit overview, and a couple of activities in relation to 910 railway station data. We'll have a break after the first activity and second activity. Then we'll go on to next steps, contacts, and the next meeting dates. Throughout the meeting, we'll be taking questions, not a problem. I will go through a couple of housekeeping points. Please raise your hand if you have a question. Please feel free to post any questions in the chat. That's not a problem, and one of us will reply to those questions. And also the contract for NaPTAN is currently under tender. We won't be taking any questions in relation to the tender. Could I have the next slide, please? Right, here's our wonderful team. We're a multidisciplinary team made up of developers, business analysts, product owners, delivery managers, and me. Next slide, please. Right, so our focus today is to understand and enhance our 910 railway station data. We would like feedback on the best way of getting new railway stations into NaPTAN, enhancing location precision, and we're going to talk through a proposal to create a new stop point record for CRS and tip-lock combinations. Now, this meeting will be quite technical, and I appreciate that not everybody on this call will work with rail data within NaPTAN. That's absolutely fine. Please feel free to make a cup of tea and just listen into the conversation. That's fine. Right, with that, I will hand over to Geeta. Next slide, please.
Yeah, thanks, BB. Hi, everyone. My name is Gitanjali, and I am the product owner on the team. So we'll start with 910 audit findings. But before I get into the details, I would like to mention that today's public meeting will be running it a bit differently from the previous one. I'll walk through the initial slides to give you an overview of 910 dataset, and then we'll move on to the audit findings. After I walk you through each audit finding, we'll move to the switch. We'll switch to the mural board for a short brainstorming session on the findings and the proposed outcomes, any feedbacks or questions you have. And if there are no comments or feedback for that particular finding, that's also fine. We can move on to the next one. So we have timed each audit discussion to make sure that we cover all the findings. So please bear with us on that. And when we get to that discussion part, we'll explain more what we need to do and we'll guide you more there. So on to the first slide. We'll start with what is 910 dataset. NaPTAN, as we know, it's an official national dataset for all public transport access points across Great Britain. That includes bus stops, tram stops, and more. Within this larger system, there is a specific 910 dataset which focus only on national rail stations. 910 is ATCO area code for rail stations. Every record link to rail station starts with 910. For instance, the one on the slides is Manchester Piccadilly. It starts with 910 and then followed by a unique identifier for Manchester Piccadilly station. Now, this data set just is not a list of station as one point. It breaks down it into its key parts, which is RLY, which is of course the main rail station record. RSC represents the station entrances. RPL refers to the platforms, and stop area is group the stations with nearby transport like bus stops, etc. Now we know what 910 dataset is. let's talk about why is it essential. The 910 dataset is important because it helps make travel smoother and more reliable. It helps in planning the journey, provide the journey planners and applications we use every day with station data. By connecting the rail stations properly with other transport modes like buses, trams, it supports a more joined up national network. It provides, if we start with the cleaner detailed data at the first step forward, adding reliable accessibility features in future would be more easier. And finally, it support better operations, help train operators and planners run services more smoothly by knowing exactly where the station entrances are and platforms are. Next, we look inside what does the station record look like. So this slide show the kind of high-level details that sits inside 910 record. First, under basic metadata, we have things like when the record was created or last updated, its version and its current status. This helps us keep track of how up-to-date the record is. Next is the identity. This is where we see the station's NaPTAN code, which is its unique ID in the system, along with station name, stop type such as RLY for the main station, RPL for platform, and RSC for the entrances. Then we have where the station is located. This part captures coordinates the lat long and the links the station to its local area through NPTG references. That's how we know exactly where it sits in the map and which town or city it belongs to. Moving to the next one, how the rail industry knows about it. So we have a CRS code, the three-letter code, which you see on your ticketing and timetables, and the tip lock code, which the rail industry uses internally for operating and for operations and scheduling. And finally, what is station connected to? This section shows how the station links to other transport modes. The plus bus zone connected to local bus services for combined tickets, and the stop area groups the station with nearby bus stops, etc., to make the network more joined up and accessible. So all these pieces together make up a digital picture of a railway station, what it is, where it is, how it is known in the system, and how it connects to everything around it. So this is the high level understanding of the 910 dataset and how it sits. Now we move on to the audit. Before I dig deeper into the details, I'll give a bit of background. So we started with initial audit to get a clearer picture of how the 910 dataset is performing, essentially to understand the data and spot any underlying issues. We compared 910 dataset against the knowledge base stations data feed, also known as stations.xml, from the Rail Data Marketplace. This gave a solid starting point to access the quality and completeness of the core station data. Following this initial audit, it was clear we need to go further to get a full picture. So we expanded our analysis to include Darwin data and SIF timetable data as well. Looking across these different sources helped us understand the complex structure and any misalignments in 910 dataset. I'll share what we have found so far and talk through the proposals that we have. So now, the analysis. Our starting point is station records, the RLY records, and that is for two main reasons. Firstly, the RLY record is the foundation. It's the core record that defines a station's identity, things like the name, code, location, and more. The more detailed records, such as the entrances and platform, they can only exist if they are linked to the main station record. So if the RLY data isn't right, nothing builds on top of it. Second, the audit gave us a clear opportunity for future work. We found that the detailed entrances and platform records are not fully available in the dataset. So this is a big opportunity for us to improve in future. So today's focus is on understanding and improving the RLY foundation, and future focus will be building on that, enriching the RSE and RPL records to give a more complete picture of each station. Now we move on to the audit findings. So our audit of RLY records begin with the basic checks to see how complete 910 data set is. We compare a 910 dataset against the official knowledge base stations data feed, and the initial results are good. There is a 99.6 coverage. Okay, this is a great starting point as that confirms our data is robust and reliable for currently active stations. But the word active here is the key. Deeper analysis confirmed that stations.xml feed, which is called the knowledge base stations data feed, includes stations that are fully operational. This is where we found our key insight that there is a natural time lag. When a new station is built, it doesn't appear in the data. This means we are always reacting to the station's opening. This finding is a significant opportunity for us. It means that we can move from reactive to a forward-looking approach by adding new stations before they are active. However, this opens a new conversation. We can't just add them. We need to decide on the right approach. As you can see from the key questions on the slide, we need to ask when is the right time to add a station, what the status should be, and what is the impact on the journey planners if we add the stations which are not yet open. So this is the first finding that we have. From here, we'll move on to the mural board. Emily, can we share the link in the chat window, please? I'll give a minute for people to join. Okay, so if you see here, this is the audit finding for the first audit finding that we have. I have written the questions over here, and for reference, I have added the slide at the bottom. So if you need reference, what we are looking for is more around if we can get any inputs from your side in terms of understanding when should we be adding the station in NaPTAN, the new station? Should it be 6 months prior or anything else as you suggest? You can add your inputs in the stickies over here. And if you want to discuss or if you have any question, please open your mic and we can discuss it here. Emily, I can't see if anybody has got their hand up. Please let me know if there is anything we need to talk about.
Yeah, we'll do. There's no hands up at the minute, so we're
Cool.
good.
Thank you, everyone, for your inputs. We are left with less than a minute. If there is anything anyone want to talk about this part, please go ahead, or else we'll move to the next audit finding. We are due over with the time, so we'll move on to the second audit finding. Yeah. So our second audit finding, it is around enhancing the data connections, which focuses on the connections between the data set. This involves a record called stop area. So what is stop area? As the slide says, it's a digital container for station. In real world, it groups the main RLY record with all the other transport links nearby, like the bus stop, entrances, and more. This is crucial for integrated journey planning. We audited these records and we found that we are in a good position. Over 90% of these links are accurate right now, which is a good baseline. This gives us a clear and manageable opportunity for enhancement and focusing on the ones which need few minor adjustments. Our action plan at this point is simple. In the short term, we are going to analyze and fix the remaining records which have some misalignments. And in the long term, we are going to implement validation rules to stop these kind of errors from happening at the first place. Now, from here, it brings us to the discussion again. And it is where we want your inputs. We need to know these codes, even though they are incorrect, they are currently live and might be used in your systems right now. We can't just change them. We need to understand the impact of us changing these stop area records. So the two questions that we have from this group today is first, how would these data corrections impact your systems? And second, if there is any more details you want to share with us on stop areas, please go ahead with that. And from here, again, we'll move on to the mural mode to discuss and talk about this second audit finding that we have. And from here, I will remove. Yeah. So this is the second section. Same again, we have the question, we have sticky, and here we will talk about the stop area records, any inputs, any feedback, any more suggestions you have. If you have any questions, please, you can go ahead and we can discuss about it. We are left with under a minute now. Just the time check. If there is anything you want to discuss, you can at any point raise your hand and we can discuss as well. We are done with the time for this audit finding. Thank you everyone for sharing your inputs on this one. From here, we move back to the presentation to our third audit finding, which is around the location precision. So here we are talking about the lat long of the rail station record. Now, while auditing, we noted a simple automated comparison of these coordinates against station.xml is not a reliable way to check the accuracy. However, to understand the level of variation, we still did a comparison with 4 decimal places. And what we found, there is a match of 60% of the stations lat long with stations.xml. So we saw that there is a need of deeper analysis. We did random spot checks to suggest, to see what is happening. And we did notice that the coordinates, station coordinates have drifted over time. They don't all consistently align with the standard, which is middle of the track. I want to be clear that this isn't a new error or a design flaw. This is a legacy data issue, and it's
Sorry.
one
All good.
we now have an opportunity to fix. So what is our plan? It's a two-step approach. First, before we begin our work, we want to formally reconfirm the standards with you, which is the middle of track, the correct agreed upon standard for our LY records. If we are aligned in that standard, then we will perform a second level of verification. This is a detailed analysis where we will review all the 2,500 plus records to ensure that they meet this single consistent standard that we are talking about. So the key questions that we have today, the first one and the most important one, are we aligned on the middle of the track as the standard for RLY location? And the second question is about how these changes might impact your system. We just want to understand any possible impacts early on so we can manage them. And if early communication is needed, we can do that. So this is around the location precision. From here, again, we will move on to the mural board for our quick brainstorming on this question. Yeah, so it's the same way. We have questions written on the top. We have stickies. Please add your questions, comments, suggestions here. And at the bottom for reference, we have the slide pasted.
We have a couple stickies relating to what is being referred by middle of the track. Don't know if you want to add anything, Geeta, to help with that. So these two slightly.
Yeah, I'll quickly pull out a image to explain myself if in the meantime people can continue.
Cool, thanks.
So if you follow me, I have pulled out a Google snapshot for Durham railway station. And if you see, when I say what we are referring to as middle of the track, this yellow sticky is what we are. The tracks are going here. And when we say middle of the track, that yellow sticky somewhere on the tracks would refer to middle of the tracks. If it is not clear, please, you can, Nicholas, please go ahead.
I was just going to point out that was never for the RSC entries, yes, the entrance is the location, but for the railway entry, it was never meant to be the center of the track. It was meant to be the sort of center of the station area. So if someone was using a journey planner and they wanted to see roughly where the station was, because there was a concept of the center of the track really doesn't work for any. If you've got a big station like Paddington or Waterloo or whatever, we've got tracks all over the place. There is no center of the tracks. So it's you know, it's erroneous to think that was what it was ever meant to be.
Okay, thanks for sharing your thoughts. It's a good one to take back and think through. It looks like there is a bit of thinking that we need to do before we agree to this standard if we want to. Nicholas, if you are okay, would it be okay for us to connect with you offline?
Yes, sure, of course. But I'm at this point, if you ask yourself the question, what is the purpose of that allocation for a railway station? It serves to give people a meaningful location for where the station is. It's not to show the internal structure of the whole station. For that, you need to have RS platform and entrance and access area points.
Makes sense.
I'd also point out that by putting location markers on tracks is not an advisable thing to do, because there are people out there who will construe that as being an accessible place to go, and you don't want to be encouraging anybody to go anywhere near railway lines.
Yes, I think these suggestions are definitely useful, and we'll take it back and yeah.
For the railway ones, have you actually spoken to anybody within Network Rail, because they're the better placed people to be able to advise you on the best places to put the markers?
Yeah, I think we need to be mindful, and I think what you stated about it is not a place where we want people to go to definitely makes a sense. We'll think through it and we'll connect with yourselves offline if you are okay, and we can
absolutely fine. I've got
yes.
a railway background, so I understand it. So
Thank you so much. Do we have any more hands up? No. So cool. From here, then we can go back again to our fourth and final finding. Oh, we have a 5 minutes break here. So everybody, please take a short 5-minute comfort break, and we'll see you in 5 minutes, which is 10:45. Thank you. Hello, everybody, again, and I hope we are back so we can continue with our audit findings. So we move on to the fourth finding, which is around the CRS and TEPLOCs. Before I dig into the details around our proposal and the concern that we have, I'll give a bit of brief of what the CRS codes and TEPLOC is. So on the left, if you see, is the passenger code, which is called the CRS Computer Reservation System Code. It's a 3-letter code that passengers see on their tickets and journey planners, such as National Rail Inquiries and others. For example, Newcastle Railway Station is represented by CRS NCL. These codes are essentially the station identifiers that the traveling public interact with. And on the right-hand side is the operational code, which is TIPLOC, which refers to timing point location. It's a 7-character code used internally for timetables, routing, and operational purposes, covering things like platforms, junctions, stations, and substations, and more. Using the Newcastle example again, its TIPLOC is NWCSTLE. These codes are mostly for operational use and ensure accurate scheduling and routing behind the scenes. Now, it's important to understand how these codes are related to each other. A single CRS code can have multiple TIPLOCs, especially in a larger or multi-level station, but each TIPLOC maps to only one CRS. Ensuring that this CRS to TIPLOC mapping is correct is essential, because then it guarantees that the data across passenger-facing systems, journey planners, and operational system is consistent and reliable. Now, which brings us to our final slide. This slide, it is a bit technical, but the idea behind it is quite simple. So we'll start with 2 common scenarios that we have came across. The scenario 1, which is called the standard station. It has 1 passenger code, but several operational codes known as TIPLOC for its different platforms or levels. So for example, a station like Newcastle might have only 1 CRS code that passenger sees, but multiple TIPLOC used behind the scenes for different parts of the station. And the scenario 2 covers the complex stations. These are much larger sites that have more than 1 CRS, which means they appear as separate passenger stations, even though they might be physically be part of the same overall complex. Each of these CRS codes will have their own set of TIPLOCs. So our audit showed that few platforms have their own stop area records. We'll review these cases to make sure everything is set up correctly. As we complete the remaining platform data, we'll ensure that we establish the standards consistently across. Now, what we are proposing here, as far as the standards are concerned for the CRS and TIPLOC combination. First, every RLY, the main station record, which is defined by the CRS code, is treated as a standalone station. Each RLY record will have its own stop point and stop area. But the platform, the RPL record, it is treated as a standalone stop point, but it will not get its own stop area. Instead, it will link back to the stop area of its parent RLY record. So these are the two standards we want to, or the proposed rules that we want to adhere to. And here we want to be aligned with yourselves as well. To get a clearer picture of these two scenarios, I'll again take you to the mural and I'll explain this with the real world example so that it makes we are clear with what we are proposing. So if you follow me up, there is a little process flow diagram. So for the scenario 1, which is the standard rail station, which have only one CRS, but it has multiple tip locks, we are taking Upminster rail station as an example here. As you can see, the CRS code for Upminster is UPM, and it has two tip locks. Tip lock 1 here, which is UPMN-SP6, and the tip lock UPMN-STR. UPMN-STR is the tip lock for RLY record, and the other one is for the platform record. As you can see, the stop area record here is created for RLY record. How you can make the distinction? You can see the tip lock for the real RLY record and the tip lock for stop area, they are same. The only difference is it is prefixed. Stop area record is prefixed by a G, which refers to GRLS system. So in this instance, RPL record is not getting its own stop area. It is linked to the parent stop area over here. That's how we will be dealing with simple standard rail station, which has only one CRS code. Now we move to the complex one, and the example that we have taken into consideration is the Waterloo station. Waterloo station, it has two stations and it uses two CRS codes, which are very geographically just 0.3 miles apart, but they have their own separate CRS codes. Waterloo station CRS code is WAT, whereas for Waterloo East, it is WAE. So in this instance, London Waterloo station with the CRS WAT, it has two tip locks. One is for RLY and the other one is for RPL. In this instance, again, the RLY record has a stop area. You can check that the tip lock for both of them are matching with a preceding G, whereas the RPL record, which is a WATRINT, it doesn't have its own stop area, but it is linked to its parent stop area. On the other hand, because there is a unique CRS code for Waterloo East station, which is WAE, it has its own tip lock, which is WLOE. It means it will have its own stop point. Being a unique station, it will have its own stop area as well. So this is how we are building up the rules in the stations where there are complex many CRS codes present for a railway station. Now we move down to the questions. There are a few questions and few considerations that we want to talk about. Does this model, which we have shared above, creating a single stop area for all stop points related to the entire station, does it seem logical to you? For the data consumer and journey planners, what is the impact of this change, if there be any? Are there any other complex layouts or edge cases that we are not aware of? And if there are, please let us know so that we provide the solution which covers the edge case scenarios as well. And finally, we are proposing to use knowledge-based stations data feed, Darwin and CF timetables data sets as our base source of truth. And we are looking for an understanding that if you also have the same understanding that these data feeds could be used as reliable sources of information. And if you are aware of any more, please feel free to let us know. From here, Emily, we can put time so that.
Yeah, how much time do you want on this one?
Let's put 5 minutes for now. I'll do that. And we'll see if we need more.
Cool.
And at any point, if you have any question or you want to share your thoughts on anything, please feel free to do that. This question, are you using all the tip locks for each of the station platform into single stop area? What we are proposing here is the main rail station record, which is referred to as RLY, would have a stop area, and all the platforms for that station would link to this stop area. That's what we are proposing here. So platforms will not have their own stop areas. They have to link back to the parent RLY record.
So are you saying that the stop point RPL is for the individual platform?
Yes.
So on the Waterloo example, you've only got one on there, whereas there's about 20 odd platforms.
Yeah.
So you have 20, say for example, there are 20 platforms. You would have 20 RPLs.
If they have unique
and
tip
all
lock,
of the, so it for Waterloo, the London Waterloo railway station, there are 20 platforms. You would have 20 RPLs, one for every single platform. And all of those will then go into the stop area, is that correct?
Yeah. So,
okay.
Yeah. So if there are 20 platforms for Waterloo Station and they are given a unique tip lock code, then yes, we will be creating 20 stop points for all the unique platforms.
Every single platform will have at least one tip lock.
Yes.
If,
so yes.
If a platform allows trains to split and divide, or you're allowed to have more than one train in the platform that can go out in opposite directions, if it's a through station, then there will be more than one tip lock per platform.
Yeah.
So what you're saying is every single one of those tip locks is then going to feed into the stop area code.
Yeah. So if there are 20 platforms with unique tip locks, it could be for the same stations with the train going in the opposite directions, whichever way operationally it is being handled, we will take all those unique tip locks for the RPLs. We'll create stop points for each RPL record individually. And then all these RPL records would link back to the stop area of the railway station. They will not have their own stop areas. So all those 20 will link
so I am
this.
right. They all feed into the stop area. Okay.
Yeah.
Okay.
My question would be, are we aligned on that this is the right approach?
I think so. So long as it doesn't preclude people from being able to use that. If it's just feeding in from a hierarchical point of view, that's fine. Where if you're wanting then to use that ATCO code for that specific platform for navigational purposes, for people's accessibility, then it can't be, you can't just use the overall one. You still need to be able to have access to that individual platform ATCO code. Does that make sense?
Yes, it does.
So from a hierarchical point of view, if you're thinking about it in the NaPTAN database itself, every area has multiple locations within it, and within that then you have all the individual bus stops, and the bus stops are then paired for either side of the road. You're doing a very similar thing here with the railway platforms, where you've got the actual station and then you've got all the individual, you're then putting all the platforms within that station. So long as each individual platform can be uniquely accessed to create a route, then the hierarchy makes sense.
Yes, I think what you're saying, it do make sense. From the access point of view, each platform would have its own stop point, which will allow that navigation aspect of it.
Yes.
But whereas the stop area basically is more around the extended transportation, for instance, the buses, etc., outside. So in that way, that hierarchical structure still works, because stop point for RPL will do the difference.
Yes, because you don't want transport going onto the platforms.
Yes. Okay. Any more questions?
We have another hand up. Sean, do you want to go ahead?
Yeah, so in terms of, because I've done quite a bit of work with the rail data, and in terms of tip locks, it's like so there isn't a tip lock for each individual platform. I think there's one exception to that, which is Aberdare, that I've seen where where for scheduling purposes they need a separate platform. And I think that's also quite a complex one, because it's also got a separate CRS code for the two different platforms, which is which is like a really unusual one. So Aberdare is definitely a station that's worth looking at, where you really don't want to have the two CRS codes. You really only want to have the one for platform journey planning purposes. Another kind of example to look at would be kind of what I think is Watford Junction, which has multiple tip locks. And part of the reason there for having multiple tip locks is for the where you've got for journey for signaling purposes, you can't route certain trains to a group of platforms. So, for example, I think it's due to whether or not they've got the DC electrification. And I think there's a number of other places where they have they'll have multiple tip locks, for signaling purposes, and preventing, for example, having a DC powered train going into getting pushed into a platform which has only overhead wires. So that's the main reason why you would have multiple tip locks. And so yeah, we won't. I think if we would like to have, I think there's really good question. Should we have a stop within NaPTAN for every single platform, and then have something else in there which then links all of the platforms and entrances together in some way? But yeah, I don't. In terms of the rail data, there isn't a tip lock for every platform.
I think from the operational point of view and for keeping the consistency across the system, so we will be taking into consideration if there are unique tip locks, as and when they come in the data feeds that we are going to refer to, the Darwin and timetables and stations.xml. We'll refer to that, and based on what data is being provided, we'll build our 910 dataset on top of the data provided by the stations teams. But for the second part, I think we need to take it back and look into it further, because we're still working on RPL. RSE, we're working on RLY. RPL and RSE is in the future scope, but we take into consideration that and keep in mind while we're working on that. So this brings us to the point where we have discussed the findings that we had based on the audit that we did. The next and the final part that we want to talk about is here. This is what we have understood, known, but if there is any more to what you want to share with us, which is not covered or you think need to be taken into consideration while we are looking into the ideation or towards the implementation phase, please feel free to add in these blue stickies and we'll take it back and we'll look into it. If anything which is not discussed, anything more you want to suggest, your feedback, concerns, please go ahead. It's this blue section over here. And we are open for conversations. If you want to discuss anything, please feel free to go ahead. We'll give ourselves, Emily did put the time, 5 minutes. So We are left with less than a minute, but please keep on adding your suggestions, and if we need more time, we'll add to the clock. We are done with the time. And thank you everyone for your inputs, time and support today, and for us understanding the wider picture and the suggestions and the feedback that you have added onto the stickies. We're gonna take it back, analyze it, and we'll bring back the outcomes in upcoming public meetings when we are ready with more details and in the implementation space we are. From here, I'll pass it back to you, Bibi. Thank you, everyone.
Thank you so much, Geeta, and thank you to everybody on this call for your participation. If we go to the next steps, Gerard, I did see your question there. Yeah, we can circulate the slides if you find that would be helpful, because I know that this is a very technical area. So next step, yeah, you're very welcome. Right, next steps. Right, we're going to use this feedback and come up with a few more solutions and update our 9-10 data set. As Geeta mentioned, we will be communicating any changes or proposed changes, and we may well have a couple more sessions in the future. We'll also communicate any updates via newsletter, and we will circulate the slides. Next slide, please. Right, so this is a request from the last public meeting. We are still looking into providing accessibility data for bus stops specifically at the moment. Thank you very much to those local transport authorities who already contacted us. We value your feedback, and if you are a local transport authority or somebody who works with NaPTAN data and you are currently undergoing an audit of your bus stops in terms of accessibility, or will do so in the future, or hold accessibility data, please contact us. We would love to speak to you. And the email address is on the screen there. It's also on our website. The next public meeting dates, the next one's in January. And we'll let you know what the subject matter will be close to the time. Next slide, please. I'd like to say a huge thank you to everybody and to Geeta, and have a great day, and we shall see you hopefully in January. Thank you.
Thank you.
Thank you.
Thank you.